As we know, it exactly contains the binary code that's none other than zeros and ones. These three are different types of languages which helps the computer systems to communicate. That's the English language what we use is called as high level language in terms of computers language. So we can directly say it is not at all humanly readable in some cases. Hello everyone, I welcome you all to this fifth session of the language, that's digital computer organization. This is the first subject under your undergraduation, that's BCA degree. So under that, this is the first unit, that's fundamentals of computers. Over here, students, my name is Deepa Gutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. I have to say, we have 4 other videos before this. So we have completed all the subtopics, or we can say all the subunits in those videos. So yes, my dear students, I just request you to have a look. So those are just filled with a lot of information regarding your topics. Yeah. So even I had told like which is a important topic on which you have to concentrate more and all this stuff. Let's continue with today's session. Before starting, let's have a quick recap of the last session. So that's session 4. Under that session 4, we did discuss like what is a software and what is the need for software. Also, we discussed the types of software. So yes, this was a so exciting and amazing session, I have to say, because this includes the whole system software thing. Yes, correct. So system doesn't work with only system or only with the hardware. So if a system has to work, both plays a same role. So yes, in our previous sessions, like in our initial session, we had discussed regarding the hardwares, and in this session 4, we did discuss regarding the software. Okay, so let's move ahead and let's see what's the agenda of today's session. So yes, in today's session, we'll be discussing about the computer languages, like what are the languages which is used in order to communicate with the computer. And also we'll be learning one more subtopic, or we can say subunit of this unit 1, that's language translators. Even you'll be learning the best language translator what we have in this era. Okay, so yes, please wait, and you'll be learning all these things, all these amazing facts in the upcoming slides. If we say languages, what comes into our mind? Yes, exactly, it paves or it bridges the way for communication between us, correct? So in the same way, even for computers, it forms the same thing. Even it forms the bridge in order to communicate between the systems, or between user as well as a system, or in between the hardwares. Okay, so let's understand what is computer languages. So yes, this computer language acts as a bridge between the human instructions as well as the machine executions. So this is nothing but computer language. So okay, when we did understand this computer language is important to communicate, it becomes crucial to understand what are the different kinds of languages which are available so that we can utilize according to our requirement, right? The different types of languages are machine level language, which we can call it as MLL, and the next one is assembly level language, which is coined as ALL, and up next is a high level language, which is also called as HLL. So yes, these three are different types of languages which helps the computer systems to communicate. Great, right? So yes, in today's session, let me tell you, we'll be discussing few amazing facts. We'll be discussing an amazing fact like which is a language which computer only understands. Also, we'll be discussing which is the language that a user provides to the computer. Just we can correlate with our day-to-day life. Okay, let's begin this session with the first computer language, that's a machine level language. When we say machine level language, students, I know you will be just recalling those machine level language, that's zeros and ones. So exactly, it's the same. So machine level language is nothing but a bit level communication. Okay, let's see how it is formed. So yeah, the definition, Machine language is the lowest level language. Exactly. It is a lowest level language. As we know, it exactly contains the binary code that's none other than zeros and ones. And we also know, right, these instructions are directly correlated to CPU because it's a machine level language. Yeah. So yes, it is directly executed by the CPU. Why it is directly executed by the CPU? Because CPU can understand this low level language quickly and it can perform or it can help execution in a quick manner. Let's understand the characteristics of this machine level language. The first character is this machine level language is written in the binary format specifically to support the processor architecture. Up next is the second character. This machine level language, it provides high level of efficiency as well as control. Why does it provide that high level of efficiency? Because there is no need of any interfaces in between in order to communicate between a CPU or this language, because CPU can understand directly this language. So we can coin as the higher efficient language. Okay. So up next, the third character is it is difficult to read, write and debug. So yes, exactly, it is bit difficult. Correct, right? It will be a combination of zeros and ones. So if it is a bit or if it is a word or if it is a byte or even it is of 1024 bytes, okay, to that extent we can manage understanding it. But if it extends that, we will be confusing that, oh my god, 0 1 0 1 1 0 1 0 1 0. It's so confusing, correct? So it will be difficult to read, write as well as debug. Okay. So up next, the last character is it is non-portable, which says like it is tied to specific processors. Okay. So yes, specific processor designs. So this is in regards to ISA, which is nothing but instruction set architecture. So by seeing this image, we can say like we can directly correlate this language can be understood directly by the CPU chip, correct? So yes, we can also say this is one of more efficient language. Great, right? So that's machine level language. So heading up, let's understand the next type of language, that's assembly level language, which is also called as ALL. Starting with assembly level language, what we can say over here is this uses the special keywords, or we can also say the information can be inputted using the keywords, which is also called as mnemonics. So what is mnemonics? Oh my god, this is some huge word which I don't understand. Yes, nothing like that. Mnemonics is so simple that if I want to say my system to move some memory space or some information from, let's say, 10 to 01 memory location, okay, so at that time what you'll use, we can use the instruction move, correct? So yes, how many letters word is a move? It's a 4-letter words, correct? So now in order to minimize and make it compact, so can this move made compact? Yes, the compact word which we can utilize in order to feed into computer is MOV, correct? Similarly, in order to add, we can use add, and in order to jump, instead of JUMP, we can use JMP. So in this way, if we go on minimizing the letters which are used to input, then obviously my memory space can be utilized for some other work, isn't it? This is the advantage of this language, that's assembly level language. Okay. Also, we can say operands, we can also use the operands instead of the binary codes. Yeah. So instead of binary codes, we'll be using mnemonics under assembly level language. Clear, right? So let's head up and understand what are the characteristics of this assembly level language. The first character is one-to-one. That is, it corresponds exactly with the machine instructions. So that's the first character. Up next is one of most best advantage of this ALL. Easy to understand compared to MLL, but it's still hardware dependent. So yes, it's far better compared to MLL, because in MLL we'll be using a set of zeros and ones, and over here we did started with mnemonics like using move, JMP for jump, and ADD for add. So these are few examples. So looking this, we can say yes, this is one of easy to use language, isn't it? Let's see what's the next character. Up next character is it requires a translator, isn't it? So yes, it requires a translator to translate it into the machine code. Okay, assembly level language, it will be in the form of letters itself, correct? There we do need a interface which is a translator. So translator is required in order to translate the assembly language words like MOV, JMP into the machine language codes. Okay. Up next character is it supports the symbolic addresses as well as the macros. The symbolic addresses we can also consider. So it supports the symbolic addresses, which we can also call as labels. Also, it can support the macros as well as the symbolic addresses. So these are few best characters of this assembly level language. Okay, so yes, you can have a look assembly level language over here. It will be in this form, like we are having ADD, MOV, and OX, OFF. So these are mnemonics. And now what has to be done? These mnemonics has to be converted back into the machine level language, correct? So which is done over here. So that's assembly level language. Clear, right? So next, let's head up with the next type of language. That's none other than high level language. It's time to reveal that amazing fact, like the language, that's the English language, what we use is called as high level language in terms of computers language. So yes, let's see what is this high level language is. High level language are closer to human languages. Yeah, so obviously it will be closer to human languages, so that it can allow the programmers to use that English letters or the syntax as well as the mathematical symbols. The English-like syntax as well as the mathematical symbols. So this is nothing but a high-level language. Up next, let's understand what are the characteristics of this language. The first character is this language is completely independent of underlying hardware. Like if it is using any external hardware or the peripheral device, we don't need to just think of those devices and write our code according to it. So we can directly write the code in this HLL. Why? Because this is independent of our hardwares. So that's independent of underlying hardware. Up next, the second character is it is easy to learn. If we understand it in a right way, then obviously it will be easy to debug. Correct, right? It will be easy to verify whether there is any errors or it is error-free. In this way, it becomes helpful in order to debug our code. And obviously, we can maintain this for a long term. So yes, that's our second character. It is easy to learn, debug as well as maintain. The third character is this HLL is compiled or it is interpreted into the machine code. So that's the next character. It is interpreted into machine code. So let's see few examples of this high level language. So it starts from C, C++, Python, Java, Fortran, and Pascal. So these are few key examples of high level languages. Over here, let's see the image. So this is all about HLL, that's high level language. So let's head up. Yeah, the comparison. Alright, now it's time to compare the three different computer languages. So let's start comparing it with respect to ease of programming. So according to our descriptions, which one is very easy to program? So yes, it's none other than the high level language which uses English text or the numerical symbols. Correct? The ease of programming is easy with respect to high level language, and it is moderate with respect to assembly level language, where we do use mnemonics, and it is very difficult with respect to what? With respect to using an array of bits. So yes, it's very difficult. Up next, let's consider the comparison aspect, readability. So obviously, which is best in order to read? It's none other than our high level language, which is highly readable. And up next is a moderate readability. We can find it under assembly level because we'll be having the keywords, correct? So it's partially readable. And what about this high level language? Yes, definitely it is not at all possible to read that, because even if we read that zeros and ones, can you understand it? So yes, you may understand, but it takes more time to convert that bits into words. Yes, it takes more time in order to convert those bits into the letters and then form a word and then read it. So it's a completely difficult task. So we can directly say it is not at all humanly readable. In some cases, there is 1024 bytes. Then you can at least read those 500, or we can also say 1000. But if it extends more, then it is highly difficult to read that. So we can say it is not at all possible to read. So not human readable. The next aspect is error proneness. So okay, which is the best under this? So yes, absolutely, it's none other than high level, and it's moderate under this assembly level, and it is very high under our machine level language. Up next, let's see the syntax, like how can we communicate with these languages. Okay, we can communicate by using binary codes, like example these 10110000. Up next, let's see with assembly language, how do we communicate? Using keywords or the mnemonics. So what are those? It's mnemonics, example MOV, ADD, etc. With respect to our high level language, how can we communicate? So yes, it's completely in English, or we can use mathematical instructions. So example A is equal to B plus C. So the next aspect is execution speed. So which language completes its action in a speedier way? That's none other than our low level language. That's a machine level language. So yes, this is one of fastest language, and the assembly level language is just fast. Okay, it is fast, but this high level language is relatively slower compared to other two languages. As it's slower, we add some interface in order to make it quicker. So that's by adding compilers along with this. So but it is optimized by adding the compilers. So this is all about the comparison of three different languages. So let's head forward. When we speak with languages, so we need some translators. As in high level language, we can see in all the aspect it is very best. But with respect to speed, it is lower speed. Why? Because the instructions will be in the English format and the system will take more time to execute that, because it becomes crucial to understand the different types of translators which are available, so that it will be helpful for us to select according to my requirement. So let's move forward. So over here, language translators. So as the name itself says, so this is used to translate the languages. Like you can translate from high level to low level, or low level to high level, or even from assembly level to low level, as well as low level to assembly level, and vice versa. Okay. So up next, let's see what's the use of this language translators. Language translator, why is it used? If you want to change your code from this high level language towards low level language, okay, or we can say the machine level language, at that point of time we need this language translators. So we can consider an example of source code. So source code is nothing but the code whatever we write, okay. So that's the information inputted in English words or letters, we can call it as a source code, okay. So now it has to be translated into the machine understandable language. That's nothing but the object code. So yes, you can observe translators are used to convert the source code into the object code. Clear? So now let's understand what are the different types of language translators available. Language translators. So we do have three different types of language translators. The first one is a assembler. The input to the assembler is the assembly language, and output what we can get from this assembler is a machine code. And over here we can say the mnemonics which are described under the assembly language code is been converted into the binary code or the binary instructions which is CPU specific. Yeah. So let's head up with the next type of translator, which is none other than compiler. This is one of very important translator which we use frequently. So the input to this compiler is a high level language. Okay. And the output what we can get from this compiler is a machine code. The main best part that I did told, yes, it is widely used. It's because, yes, it converts the whole program at single execution. Okay. So yes, over here you can observe converts the whole program at once. So what we can say, the execution is fast. Yeah. So that's the best translator we do have. Okay. So let's see the next one. That's none other than interpreter. Okay. So in interpreter, the input will be high level language as well as the output. What we get from this interpreter is expected to come line by line. So we can describe it translates the information line by line. So what we can say, it is time consuming task and we need to run the program each and every time. So that's all about interpreter. Guys, I had told you we'll be discussing about the best language translator, what we have. It's time to reveal that. And I think you might have guessed it. So it's none other than compiler. Okay. So this is one of the best language translator what we have. This is the completion of your first unit, that's fundamentals of computer. So we took 5 sessions to complete this unit because it is having multiple subunits under that. Yes, I would like to say please go and watch all those 4 videos, and also we do have day 0 video which gives a bird's eye view on the complete syllabus of DCO. Okay. Not to worry, this is one of the best subject of your undergraduation degree. So yes, you can learn complete fundamentals of your computer system all along this unit. Yeah. So over here, let's stop and let's see you in the upcoming chapter. So let's see you in the upcoming unit. Thank you.